Students, first of all, I welcome you all to the new class. This is really a career orientation class, that is class 12. You all must be knowing our country is facing a lot of crisis due to the deadly coronavirus, which has become an epidemic throughout the country. Our school has decided to give you teaching through video lectures. Here, for the sake of your convenience, I am giving you the teaching on electrochemistry. This is the second chapter of class 12 chemistry. Electrochemistry. Now we have certain specific terms in this unit, and these are electrochemical cells, electrolytic cell, electrode potential, a standard electrode potential, etc. Students, all these terms we have already discussed in class 11 also, in the chapter redox reaction. You might be knowing. However, we have to recapitulate all these things once again, because these are very, very important to have better concept in this chapter. We define all these terms. We start from the chapter electrochemistry. It is a branch of chemistry which mainly deals with the interconversion of chemical energy and electrical energy and vice versa. Now, electrochemical cell. Electrochemical cell is a device which converts chemical energy into electrical energy. Electrolytic cell is also a device which converts electrical energy into chemical energy. Now we come on to electrodes. Electrodes are the conducting materials at which ions get discharged. There are of two types. One is anode and the other is cathode. Anode, you know, the electrode at which oxidation takes place, and the cathode is an electrode at which reduction takes place. You might be knowing. Now we come on to electrode potential. It is a measure of the tendency of oxidation or reduction when an electrode is in contact with its electrolyte. Say for example, here we can draw a simple diagram for an electrode. Here is metal, here is electrolyte that is represented by Mn plus aqueous for electrolyte and M for metal. Now symbolically it is also represented like this: Mn plus N. This is general representation of electrode reaction. The forward reaction evidently it is oxidation, and the backward reaction is reduction. Once again, oxidation takes place at anode and the reduction takes place at cathode. Now, electrode potential, representation of electrode potential. This is represented by Mn plus interface with M or M interface with Mn plus. We can represent electrode potential like this. Now it is divided into two parts. One is oxidation electrode potential, another is reduction electrode potential. Now oxidation electrode potential, oxidation electrode potential. Now the electrode potential associated with anode is called oxidation electrode potential, and it is represented by Em interface with Mn plus. Here M changes to Mn plus by loss of one electron. So loss of electron is oxidation. That's why the potential associated with anode is called oxidation electrode potential. Similarly, we have reduction electrode potential. Clearly, it is indicated by Mn plus interface with M or in contact with M. Here, when Mn plus gains electron, it is converted into M. Now, these two electrode potentials, when connected, it forms an electrochemical cell. So, electrochemical cell can be represented as electrochemical cell can be represented as M1 Mn plus, here is C1, then a salt bridge which is represented by parallel line, M2 N plus C2, here is concentration C2, concentration of electrolyte, and this is M2. So left hand side represents anodic compartment and right hand side represent cathodic compartment according to the international convention. That means anode is always kept in the left side and cathode is kept in the right side. Now, on the basis of this electrochemical cell, we can draw three things. Number one is anode reaction. Anode reaction, by this electrochemical cell can be written as M1 N plus Ne. Here loss of electron is shown. Second one is cathode reaction. Cathode reaction is represented as M2 N plus. By gaining Ne, it becomes M2. So anode reaction, this is cathode reaction. Now third one is cell reaction. And the cell reaction is obtained by adding anode reaction and cathode reaction in balanced form. So we can write M1 plus M2 N plus M1 N plus M2. This is complete cell reaction. Standard electrode potential. Standard electrode potential is electrode potential of an electrode at a condition 298 Kelvin and 1 atmospheric pressure. Atmospheric pressure using 1 molar concentration of electrolyte. It is represented by E naught Mn plus M. This is also represented by a standard reduction electrode potential according to International Sign Convention. Now we have a relationship between oxidation electrode potential and reduction electrode potential as E naught Mn plus interface with M is equal to minus E naught M interface with M plus. Simply by changing the sign, we can correlate these two potentials. Here are few questions on electrochemical cell. Question number 1 is write anode reaction, cathode reaction and cell reaction for the cell Al3 plus Ag plus Ag. Second one is the balancing factor like this.